In this video, we're going to start talking about normal distributions. Let's see what normal distributions are but with an example. Suppose a friend is pregnant and is due to give birth on June 30th. Would you advise her to schedule an important business meeting for June 16, 2 weeks before the due date? Okay. So let's look at this figure. The figure is a histogram for a distribution of 300 natural births. The left vertical axis shows the number of births for each 4-day bin. The right vertical axis shows the relative frequencies. So basically, you've seen distributions before. Basically, that this just shows a distribution of how many births based on days before or after the due date. The 0 is the actual due date, and the negative numbers are how many births before the due date. The positive numbers are days after the due date, and the height of the bar is how many births fit within each category. We can find the proportion of births that occurred more than 14 days before the due date by adding the relative frequencies for the bins to the left of -14. So -14 represents 14 days before the due date, and all this these bars, the bins here, are the days greater than 14 days before the due date. So if you add the values, if you add the heights of the bins, then you get the proportion of births that occur more than 14 days before the due date. These bins have a total relative frequency of 0.21, which says that about 21% of the births in this data set occurred more than 14 days before the due date. This particular distribution is called the normal shape. We've seen all kinds of distributions, symmetric, left skewed, right skewed. Now we're going to focus on this particular shape, the normal shape, and it's also called a bell shape because it looks like a bell. If you draw a smooth curve on top of the distribution, it looks like a bell. The distribution of the birth data has a fairly distinctive shape, and it basically fits in this bell shape, the normal distribution shape. Typically, as many births will occur after the due date as before the due date, and most of the births are clustered around the due date. So this normal distribution has 3 very important characteristics. This distribution is single peaked. Its mode is the most common birth date, and it is the due date. And this is typical of all distributions that have this normal distribution shape. The distribution is symmetric around this single peak. So its median and mean are the same, and its mode is the same. So that's one property of normal distribution, that the mean, median, and mode are the same. The median is the due date because equal numbers of births occur before and after the due date. The mean is also the due date because for every birth before the due date is a birth of the same number of days after the due date. And the third characteristic is that the distribution is spread out in a way that make it resemble the shape of a bell. So we call it the bell-shaped distribution. Now, normal distribution and bell-shaped distribution could have the same mean but look quite different. And it can look different if based on the standard deviation. In the first figure, in the figure on the left, it has a larger standard deviation. That means the data values are more spread out. And in the figure on the right, there's a smaller standard deviation. The data are clustered closer to the mean, closer together. Both distribution are normal and have the same mean of 75, but the distribution on the left has a larger standard deviation. So to summarize, the normal distribution is a symmetric, bell-shaped distribution with a single peak. Its peak corresponds to the mean, median, and mode of the distribution, and its variation can be characterized by the standard deviation of the distribution. So we're basically going to spend this whole week, this whole unit, looking at different examples that fit within the normal distribution and different characteristics, different properties of the normal distribution, and how you can use those to answer certain questions.